So here I'm going to talk about elasticities, profits, and revenues for principles of microeconomics. I cover these concepts in all my principles classes. They come up in a bunch of different sections. It's also really useful, for our higher level course. I teach international trade, and so we talk about income elasticity and other elasticities in that class. Basically, I can apply these formulas. I've got the simple elasticity formula, which is the change in quantity over change in price. I've got revenue, which is price times quantity, and then profit is revenue minus costs. Okay. Now it's really important. The way I do it, I don't do the midpoints formula as much. This is the simple elasticity formula. The reason why people use the midpoints formula is because you can't use calculus in a principles class. The way I always say it is that if you go from 4 to 5, it's a 25% increase, but if you go from 5 to 4, it's a 20% decrease. So the range is different in both directions, right? But if the range gets bigger, go from 4 to 8, it's a 100% increase, but from 8 to 4, it's a 50% decrease. So now it's an even bigger difference between the two directions. Calculus does everything at a point, meaning that there's a range of 0, so there's no worry about having two different answers. The midpoint takes the averages of those two ways. Right? So I'm just going to do the simple formula. Right? I'm also not going to do income elasticity or cross price right now. Basically, though, one thing to point out is that elasticity is always negative. So sometimes people just do the absolute value. And then you always say it's greater than 1. It's greater than 1 in absolute value. Okay. Income elasticity could be negative for an inferior good or positive for a normal good. So then positive and negative matters. Same thing for cross price elasticity with substitutes and complements. Right. So what I'm going to do is I've got P and Q, which is simply a linear demand function. As price goes up or down by $1, quantity goes up or down by 1 unit. And so it's pretty simple as a slope of 1. All right, and then I'm going to calculate elasticity, revenue, marginal cost, total cost, and profit. I'm keeping total cost simple. I don't have any fixed costs. I'm just adding the marginal costs together. Okay, so if I've got P going down by 1, Q goes up by 1, we're going to take it as percentages though. All right, and so over here I kind of broke it up into two parts. If you go from let's say over here, and I've got the formulas here. If you go from 12 to 11, you lose a 12th, which is 8%. And then if you go from 1 to 2, you gain 100%. Well, if you take these two ratios over each other, you get 12. All right, so this 1 over 0.08 gives you 12. The elasticity is negative 12 or 12 in absolute value. If you do it again, even though it drops by 1, this is now like 9%, and this is only 50%. You divide the two, and you get about 5.5. Keep going. This is a 10% change, and this is a 33% change, and then you get 33 over 10, or 3.3. So these are the elasticities. Now notice the elasticities are falling in absolute value, and eventually they get to be lower than 1. Right? Now if you draw this over here, you find that this is the demand curve with a slope of negative 1. All right, and then if you remember from your textbook or your class, this is the elastic range, and then over here is going to be the inelastic range. Okay, so this is how you calculate elasticity using the simple formula. There's two parts. You take the percentage change in Q, right, from 1 to 2, and then you divide by the percentage change in P from 12 to 11, and you do it all along the demand curve. Okay. Now, to get revenue, it's simply P times Q. So you just multiply the two. 13 times 0 is 0, 12 times 1, 11 times 2 is 22, and so forth. Notice that it starts to peak right over in the middle, and then it starts to fall. 4 times 9 is 36. So you get this revenue curve over here that peaks right around the point where the elasticities turn. Okay? And that's going to be your maximizing point for the monopolist as well. Okay, so if you're going to maximize revenue, you're going to do it right in the middle, or you're not going to expand indefinitely like a competitive firm might. Okay, marginal revenue is the difference between the two. So every additional unit, you simply take the difference. 12 minus 0 is 12. 22 minus 12 is 10. Right? So we find out that as we're moving along the quantity curve, revenue is increasing. So this firm is producing more and more, and their revenue is rising. And then you can actually find that at some point it's going to peak and start to fall. And so this is simply the difference in PQ. Right? So we've already calculated PQ. So from 30 to 36, the difference is 6. From 40 to 36, from 36 to 40, it goes up by 4. But after it peaks, from 42 to 40 is negative 2 and so forth. Now again, it never quite lines up because in Excel you have to, you're not having 7.2 or you don't have anything intermediate. It's discrete. But somewhere in here, the elasticity goes from above 1 to negative 1, above 1 to below 1 in absolute value, right around the same point revenue peaks. And because it's peaked and it's starting to fall, marginal revenue is negative. All right, so this is where you get the marginal revenue curve that is going to basically it's going to start high, and then it's going to go to 0, and then it's going to fall. So I have it here. This is constant. It's constantly dropping by 2, and so it's got a constant slope. A marginal revenue eventually crosses 0 and eventually becomes negative, right? So you can calculate all of this with just P and Q. P and Q gives revenue, and revenue can make marginal revenue, and then P and Q changes make elasticity. Now, this number I did make up. I just made marginal cost going up by 1. I made it for simplicity's sake. It's not really based on any of these numbers over to the left, but marginal costs are rising. And then total cost is simply the sum of all previous ones. So 0 plus 1, 0 plus 1 plus 2, and so forth. So my total cost, I keep it simple by just adding the marginal cost. All right. Now, to get the profit, it's revenue minus cost. Okay, so 22 minus 1 is 21. Keeps going, 30 minus 3, 36 minus 5, and so forth. But you can see here that there's a maximizing point here. So again, you could maximize revenue. If you want to maximize profit, you're going to there's going to be a point, right, that's sort of a low quantity where profit is maximized, and that's going to be where the monopoly firm operates, right? So again, some firms might want to maximize revenue, but if you're going to be a profit maximizer, you're going to do the profit maximizing decision of P is greater than MR equals MC, you find out it's going to be a slightly lower quantity, right? It's not, revenue maximizes over here somewhere, all right, quantity around 8, let's say, all right, but the profit maximizing point is going to be a little bit lower, okay? So here's the profit, and you can make the profit curve as well. You can see that it starts low. It goes 21, 27, 30, up to 33, and then it goes down and becomes negative, right? So these curves are actually based on the numbers in Excel. You can find the profits maximized around 6, and eventually you start to lose money if you produce too much, right? So that's kind of what I can show. And if you know the monopoly graph, this is using these numbers to make the monopoly graph. You might have a competitive type firm producing where P equals MC, right? The demand is P equals MC. They're going to produce more at a lower price. But the profit maximizing point for a monopolist is going to be a little bit lower. You can see right here it's around 5. And that's where MR equals MC. And then because they have market power, they raise the price. You can actually move over to here. You can find out that the price is about 8 or so. All right, but they actually can charge a little bit more. So the competitive firm might produce over here with a price of, say, let's say 6, all right, and a quantity of 6, or excuse me, a quantity of 8. But the monopoly firm is going to cut back to a lower quantity and a higher price. So that's kind of one of the takeaways if you talk about monopoly versus competition, right? Competition has a lower price and higher quantity. Competition has a lower price and higher quantity. Monopolist has a higher price and lower quantity, and they're actually able to make a profit because they operate at that profit maximizing point. But you're able to show that with all the numbers I made up here, right? Simple downward sloping demand curve, and I was able to make revenue, marginal revenue, and then I was using some more numbers to make profit. Now, again, this, if you were to look at, this is the elastic range, this is the inelastic range. This elasticity curve actually shows you that at the higher prices, its demand is elastic, lower prices, it's inelastic. So these numbers are able to show a lot of the graphs you might see in your textbook. At the same time, I was able to use Excel to use the formulas and calculate the numbers. So I used the formulas to make numbers in a table, and then I made tables and matched them into a graph, and then we're able to show the concepts from microeconomics.